Good day everyone. You have learnt in differential equations variable separable type and homogeneous differential equations how to solve those two types. Now today you will learn type 3 which is linear differential equations. This will be of the order first order. Now the equation will be of the format dy by dx plus py is equal to q, where p and q are constants or x terms only. That is very important. There is of course another type, but which is not for this year syllabus. So I am just teaching this type now. So now the linear differential equation will be of the format dy by dx plus p into y, that is equal to q. Here the important condition is p and q will be either constants or they will be only x terms. Here just there are two steps you have to remember, two main steps. One is you will be finding integrating factor, okay? You will be finding integrating factor which we denote by IF. For that the formula is e power integral p dx. So this is the IF formula. Then the step 2 is you will write the solution as y into IF, that is equal to integral q into IF dx plus c. These are the two main steps you have to remember. So first the given differential equation should be of this format, otherwise you have to bring it to this format. Here there shouldn't be any coefficient before the dy by dx. Then check whether your p and q are constants or x terms. Then only we can apply this. Now here first you will be finding integrating factor which is simply known as IF. For that the formula is e power integral p dx. Once you find the IF, then you can straight away write the solution is y into IF is equal to integral q into IF dx plus c. So this part only you have to integrate and this will be your required general solution. If they give some values for x and y, you will be evaluating the c and then that will be your particular solution. So now let us see one example first. Okay. So now I will take a sum dy by dx plus 2y tan x, that is equal to sin x. You have to solve this differential equation dy by dx plus 2y tan x is equal to sin x. Now this is a sum which is straight away of the form, you just compare it dy by dx plus py is equal to q. This is of this format. Here the p will be 2 tan x because that is the coefficient of y. So the p is 2 tan x and the q is equal to sin x. So you can write the given differential equation is of the form dy by dx plus py is equal to q, where p is 2 tan x and q is sin x. Okay. Now you know you have to find integrating factor, that is e power integral p dx. That will be e power integral p is 2 tan x. Let me write the 2 outside the integral tan x dx. Now integral tan x, we have actually got two formulae. One is log mod secant x, other one is minus log mod cos x. You can use either one. I am going to use e power, that 2 I will write as it is. I will write now log mod secant x. Here don't write c because in the solution we have a c. So e power 2 log mod secant x. Now this is like b log a. So I can write it as log a power b. Remember the log rule. So now I will be getting this is equal to e log mod secant squared x. Okay. So now this e and this log are reciprocal functions. So you will be getting your if is equal to nothing but secant squared x. So this is the first important step you have arrived at. After this, you can straight away write. Now the solution is y into if is equal to integral q into if dx plus c. So y secant squared x is equal to integral. What is q? Q is sin x. So write sin x. If is secant squared x dx plus c. Dx plus c. So you will be getting integral sin x secant squared x dx plus c. Now let us keep this as it is. Here I can write this is sin x. Secant squared x is nothing but 1 by cos squared x dx plus c. Now you can sin x by cos x is tan x and 1 by cos x is secant x. So you can write the integrand as integral tan x secant x dx. Like that you can write. Okay. So now you can write y secant squared x is equal to integral tan x secant x dx plus c. Now you know it's a straight formula. So you have here secant x plus c. Here you have y secant squared x, right? Now, if you want to give it in a big format, you can divide the whole thing by secant squared x. So I will get y is equal to secant x by secant squared x will be 1 by secant x, which I can write it as cos x. Okay. Then here I will get c by secant squared x, which I can write c cos squared x. So this is the required general solution. So do you understand this? So first what you are doing, you are finding the integrating factor. Then you are writing the solution. Y into if is equal to integral q into if dx plus c. Then that part you are integrating and you are arriving at the final thing. If you can simplify, you can simplify it. Let me now teach you one more example of this, which is slightly different, so that it will be clear to you and you will be able to do any sum of this type. Now let me take the example. X cos x dy by dx plus cos x plus x sin x into y, that is equal to 1. Okay. Now the first sum was very straight. You were able to immediately say that is of the format and you know what is p and what is q. Now you have got before dy by dx one x cos x. You have got here two terms for y. Here you have got a constant. No, straight away it is not of that format. So I told you there shouldn't be any coefficient for dy by dx. So now let us divide the total equation by x cos x. So what will I get now? Dy by dx plus cos x plus x sin x divided by x cos x. Okay. Then y here, that is equal to 1 by x cos x. So I have divided the total equation by x cos x. Now I have got dy by dx plus some p into y. Everything is in terms of x. That is equal to q. But let me simplify it a bit and then I will write my p. So I will do one more step. Dy by dx plus cos x by x cos x will give you 1 by x. X sin x by x cos x and x will get cut and I will be getting a tan x. Then y, that is equal to 1 by x cos x. Now this is of the form I can write dy by dx plus py is equal to q. Now my p is equal to 1 by x plus tan x and q is equal to 1 by x cos x. Okay. So now I have found out what is my p and what is my q. What is the next step now? You have to find the integrating factor. So now I will write if is equal to e power integral p dx. That is equal to e power integral 1 by x plus tan x dx. Now I have got two terms with a plus in between. So I have to integrate them separately. So now I will get e power. For 1 by x, I know it is log mod x. Here for this tan x, I am going to write it is log mod secant x. Okay. Then I have now integrated. Now this is like log a plus log b, which I can write e power log mod x secant x. That e and log are reciprocal functions. So I will be getting my if is equal to x secant x. I can write x secant x or I can write x by cos x, whatever it is. So now this is my if. So once I have got my if, next I can go for the solution step. Okay. So what is the solution step? Y into if, that will be equal to, okay. Now the solution is y into if is equal to integral q into if dx plus c. So I will get y into x secant x. Okay, y x secant x, that is equal to integral. What is q? 1 by x cos x into if is x secant x, then dx plus c. This x and this x will get cut. Okay. This 1 by cos x is nothing but secant x. So I can write it as secant squared x dx plus c. You know integral secant squared x is nothing but tan x. There is a straight formula. So now I can write this is equal to tan x plus c. Here I have got y x secant x. Now I can simplify it in one more step. I will write here yx, I can write xy, that is equal to the secant x I will bring here. So tan x by secant x plus c by secant x. Okay. Tan x is what? Sin x by cos x. Secant x is 1 by cos x. So that cos x and cos x will get cancelled. I will be getting a sin x here. Here I can write this is c cos x. Here I am having xy. So xy is equal to sin x plus c cos x is the required general solution. So hope these two examples are clear to you. As I told you, the other type, the other format is not there for this year exam. It is deleted in the syllabus. So now this is enough for you to know this type. Thanks for watching the video. You can subscribe to the channel and click the bell icon to get notification of further videos.